Atomic. This is the first generation of nuclear weapons, and it fundamentally changed the nature of warfare forever. A fission weapon works by splitting the nuclei of heavy, unstable atoms, typically uranium-235 or plutonium-239. When a neutron strikes one of these nuclei, it splits apart, releasing enormous amounts of energy and additional neutrons. These newly released neutrons then strike other nearby nuclei, triggering them to split as well. This creates an instantaneous, exponentially growing chain reaction that releases devastating power in a fraction of a second. There are two primary design approaches for atomic bombs. The first is the gun-type design, which is mechanically simple but requires highly enriched uranium. In this design, one subcritical piece of uranium-235 is fired down a barrel into another subcritical piece, bringing them together to form a supercritical mass. The moment this happens, the chain reaction begins. This was the design used in Little Boy, the bomb dropped on Hiroshima on August 6, 1945. It had a yield of approximately 15 kilotons and killed an estimated 70,000 people instantly. The second approach is the implosion-type design, which is more sophisticated and can use plutonium-239. In this design, a sphere of fissile material is surrounded by carefully shaped conventional explosives. When these explosives detonate simultaneously, they create an inward-focused shockwave that compresses the plutonium core to tremendous density, initiating the chain reaction. This was the design used in Fat Man, dropped on Nagasaki on August 9, 1945. It had a yield of approximately 21 kilotons. The implosion design is more complex but more efficient and remains the foundation of modern nuclear weapons. The power of atomic bombs is measured in kilotons, where 1 kiloton equals the explosive force of 1,000 tons of TNT. While devastating, atomic bombs represent only the first step in nuclear weapon development. The largest pure fission weapon ever tested was around 500 kilotons, as there are practical limits to how large a fission weapon can be built before the reaction becomes inefficient. Hydrogen bombs, also called thermonuclear weapons, represent the second generation of nuclear weapons and are far more powerful than atomic bombs. A fusion weapon works by forcing the nuclei of light elements to combine or fuse together under conditions of immense heat and pressure. The most common fuel consists of isotopes of hydrogen, specifically deuterium and tritium. When these light nuclei are forced to fuse, they release vastly more energy per unit of mass than fission reactions. The challenge with fusion is that it requires temperatures of tens of millions of degrees to occur, temperatures found naturally only in the core of stars. The ingenious and terrifying solution was to use a fission bomb as a trigger. In essence, an atomic bomb detonates first, creating a temporary man-made star that provides the extreme conditions necessary to ignite the fusion reaction. This is why hydrogen bombs are sometimes called two-stage weapons. The most common design is the Teller-Ulam configuration, named after physicists Edward Teller and Stanislaw Ulam, who developed it in the early 1950s. In this design, a fission primary and a fusion secondary are placed at opposite ends of a radiation case. When the primary detonates, it releases an intense burst of X-rays that are reflected by the case to compress and heat the fusion fuel to the point of ignition. The fusion reaction then releases even more neutrons, which can cause additional fission in a uranium tamper surrounding the fusion fuel, further multiplying the yield. The power of hydrogen bombs is measured in megatons, where 1 megaton equals the explosive force of 1 million tons of TNT. The largest nuclear weapon ever detonated was the Soviet Union's Tsar Bomba, tested on October 30, 1961. It had a yield of approximately 50 megatons, roughly 300 times more powerful than the Hiroshima bomb. The mushroom cloud rose to a height of 40 miles, and the shockwave circled the Earth 3 times. Importantly, Tsar Bomba was actually designed as a 100 megaton weapon, but was deliberately reduced to 50 megatons for the test, demonstrating that there is essentially no upper limit to the destructive power of thermonuclear weapons. Strategic nuclear weapons are not defined by their physics or design, but by their intended purpose and the role they play in military doctrine. Strategic weapons are high-yield thermonuclear devices specifically designed to destroy entire cities, major industrial centers, or hardened military command posts deep underground. These are weapons of mass destruction in the most literal sense. The primary role of strategic weapons is deterrence, not actual use. They underpin the doctrine of mutually assured destruction, often abbreviated as MAD. The logic is simple but chilling. If any nation launches a nuclear first strike, the targeted nation will retain enough surviving weapons to launch a devastating retaliatory strike that will annihilate the attacker. The certainty of this mutual destruction is intended to make nuclear war unthinkable. Strategic weapons are built to be delivered over vast intercontinental distances by what is known as the nuclear triad. The first leg of the triad consists of land-based intercontinental ballistic missiles, or ICBMs, which are housed in hardened underground silos. The second leg consists of submarine-launched ballistic missiles, or SLBMs, carried by nuclear-powered ballistic missile submarines that patrol the oceans in complete secrecy. The third leg consists of long-range strategic bombers capable of carrying nuclear cruise missiles or gravity bombs. This three-pronged approach ensures that even if one or two components are destroyed in a surprise attack, the surviving leg can still carry out devastating retaliation. Strategic weapons typically have yields ranging from hundreds of kilotons to several megatons. A single modern strategic warhead can completely destroy a major metropolitan area. The United States and Russia each maintain arsenals of thousands of strategic nuclear weapons, with significant numbers also held by China, France, and the United Kingdom. Tactical nuclear weapons, also called non-strategic nuclear weapons, represent another category based on intended use rather than design. Tactical weapons are smaller, lower-yield nuclear devices specifically designed for use on a battlefield rather than against cities or strategic targets. They typically have yields ranging from a fraction of a kiloton to a few tens of kilotons. The theory behind tactical nuclear weapons is that they could destroy specific military targets, such as a concentrated tank formation, an enemy airfield, a hardened command post, or a naval fleet, without automatically escalating to a full-scale strategic nuclear exchange. The idea is that these weapons could provide a decisive advantage in a conventional war while remaining below the threshold of all-out nuclear war. Tactical nuclear weapons can be delivered by a variety of systems, including short-range ballistic missiles, artillery shells, depth charges for anti-submarine warfare, air-to-air missiles, or bombs dropped by fighter jets. During the Cold War, the United States and Soviet Union developed and deployed thousands of tactical nuclear weapons, and many remain in arsenals today, particularly in Russia's stockpile. However, tactical nuclear weapons are highly controversial, and their utility is questioned by many military strategists and political analysts. The fundamental problem is that most experts believe the use of any nuclear weapon, no matter how small or how limited the intended target, would inevitably cross a critical psychological and political threshold. Once nuclear weapons are used in combat, the pressure to escalate to larger weapons and strategic strikes would become overwhelming, making all-out nuclear war highly probable. This is known as the escalation problem, and it makes the concept of a limited nuclear war extremely dangerous. Neutron bomb. The neutron bomb, officially called an enhanced radiation weapon, is a specialized type of low-yield thermonuclear weapon with a unique and controversial design purpose. It was developed during the Cold War specifically to maximize deadly neutron radiation while minimizing the physical blast and heat effects that characterize conventional nuclear weapons. The grim and specific purpose of a neutron bomb is to kill soldiers, especially those protected inside armored vehicles like tanks, while leaving buildings, roads, and infrastructure relatively intact. The weapon achieves this by using a fusion reaction that releases an intense burst of high-energy neutrons. These neutrons can penetrate steel armor and concrete that would protect against blast and heat. When these neutrons pass through living tissue, they cause immediate and severe radiation poisoning that is rapidly fatal. A neutron bomb typically has a yield of only 1 to 10 kilotons, much smaller than strategic weapons. However, the neutron flux it releases is far more intense than a standard nuclear weapon of the same yield. Within a radius of several hundred meters, the neutron radiation would be immediately lethal to anyone not inside heavily shielded structures, while beyond that zone, people would suffer severe radiation sickness. The United States developed and tested neutron bombs during the 1970s and 1980s, and they were briefly deployed in Europe as part of NATO's defensive strategy against a potential Soviet tank invasion. However, they generated significant public controversy and were seen by many as particularly inhumane weapons. Most neutron bombs were never mass-produced, and the ones that were deployed have since been decommissioned and removed from active arsenals. Bunker buster. The nuclear bunker buster, officially known as an earth-penetrating weapon, is a nuclear weapon specifically designed to destroy deeply buried and heavily fortified targets that would survive a surface or airburst nuclear explosion. These targets include underground command bunkers, deeply buried weapons storage facilities, and hardened ICBM silos protected by hundreds of feet of reinforced concrete and rock. A bunker buster consists of a nuclear warhead housed in an extremely strong, hardened steel casing with a pointed aerodynamic nose cone. The weapon is not designed to drill or tunnel through the earth. Instead, it uses its immense kinetic energy from being dropped at high speed to penetrate tens or even hundreds of feet into solid ground or rock before its warhead detonates. The key advantage is that an underground nuclear explosion creates a far more powerful and focused ground shock wave than an airburst, making it exponentially more effective at destroying buried structures. The B-61 Mod 11 is the primary example of a nuclear bunker buster in the United States arsenal. It was specifically designed to hold North Korean and other adversaries' leadership bunkers at risk. It has a variable yield that can be adjusted from less than 1 kiloton to approximately 400 kilotons, allowing it to be tailored to specific targets. The weapon is carried by B-2 stealth bombers to ensure it can penetrate enemy air defenses. The concept of bunker-busting nuclear weapons is controversial because their existence lowers the threshold for nuclear use. Unlike massive strategic weapons designed only for deterrence, bunker busters are explicitly designed to be usable in certain military scenarios, which some analysts fear makes nuclear war more likely rather than less likely. Salted bomb. The salted bomb is a theoretical type of nuclear weapon, often referred to as a doomsday device, that has never been confirmed to have been built, but remains one of the most terrifying concepts in nuclear weapons theory. A salted bomb consists of a standard thermonuclear weapon that has been intentionally salted or loaded with certain stable materials such as cobalt-59, gold-197, or tantalum-181. When the bomb detonates, the intense neutron flux from the fusion reaction transmutes these stable elements into highly radioactive isotopes. In the case of cobalt, the stable cobalt-59 is converted into cobalt-60, which has a half-life of approximately 5.3 years and emits extremely intense gamma radiation. This radioactive material is then dispersed over a vast area as nuclear fallout, creating a zone of lethal radiation that would persist for decades. The purpose of a salted bomb is not to win a war in any conventional sense. It is a weapon of area denial and long-term environmental destruction. A sufficiently large salted bomb could render hundreds or thousands of square miles completely uninhabitable for human life for generations. It represents the ultimate expression of mutually assured destruction, a weapon that guarantees not just the destruction of the enemy, but the poisoning of the Earth itself. The concept was first proposed by physicist Leo Szilard in 1950 as a way to illustrate the dangers of the nuclear arms race. While some nuclear weapons tests have incidentally created small amounts of long-lived radioactive isotopes, it is believed that no nation has ever deliberately constructed a salted bomb for deployment. Such a weapon would serve no rational military purpose and would be an act of global genocide. Thanks for watching. Which of these weapon types do you find most concerning, and do you think the world will ever achieve complete nuclear disarmament? Let me know in the comments. Also, be sure to like and subscribe if you found this informative.